tabular method is better usually than the integration by parts formula because it's faster and it's more efficient when you have to use the integration by parts formula a multiple number of times. So today we'll be looking at 3 different problems that make you use the tabular method in 3 different ways. So let's take a look at the integral of x squared times e to the x dx. The very first thing you have to do in the tabular method is create 3 columns. So we have our u column, dv column, and we have a sign column, a sign chart column, so plus minus. So just like the integration by parts formula, you have to choose your u and your dv. So in this case, x squared is the polynomial, so I'll choose that as my u and e to the x as my dv. And for the sign, we always start with a plus and we'll alternate plus minus for every row. So for the u column, all we have to do is derive that column. So I'm actually going to derive x squared to 2x. The derivative of 2x is 2. And I'm going to go all the way down to 0. The derivative of 2 is 0. And then for the dv column, we integrate. And the integral of e to the x is e to the x, and it'll continue being e to the x. And then for the signs, we can just do alternate plus minus and plus minus. So now what I'm going to do is create arrows. So I'm going to start with x squared. I'm going to go down right to e to the x, and then to the right to the sign. Same thing with the second row, and same thing with the third row. And we don't do it for the very last row where there's 0. We just leave that one alone. So now what I'm going to do is I'm going to multiply the ones that are connected by arrows. So in this case, we're going to multiply x squared and e to the x, so x squared times e to the x. And then I'm going to use this sign here. Let me go minus the next row, then 2x times e to the x. And we have a plus there, so plus the next row, which is 2 times e to the x, so 2e to the x. We have minus, and then for this very last row, all we have to do is multiply them and put them in an integral. So we have minus the integral of 0 times e to the x dx. And this is pretty nice because 0 times e to the x is 0, and the integral of 0 is just 0. So our final answer is x squared e to the x minus 2x e to the x plus 2 times e to the x plus c. Finally, let's take a look at the integral of e to the x times sine of x dx. So once again, I'm going to make the u dv and plus minus sign columns. So I'm going to pick u as e to the x. Now I'll pick dv as sine of x. Once again, I derive the u column and integrate the dv column. So I go e to the x, and you'll notice that as I derive u, it will just go on forever as the same e to the x. But if I integrate dv, the integral of sine of x is negative cosine x, and the integral of negative cosine x is negative sine x. So these will go on forever, just like the previous problem. But we cannot stop at the first integrated row because that wouldn't work. We have to stop at a multiple. And so this last row here, e to the x times negative sine x, when we multiply those two together, they will be a multiple of e to the x sine of x, just with the negative. So once again, I'm going to make the arrows. So now we multiply e to the x and negative cosine x. So negative e to the x times cosine x minus a negative e to the x times sine of x. It's a minus a negative, so I can change that to a plus sign. And then we have plus the integral of the last row multiplied. So we have negative e to the x times sine x dx. So now I can actually move this negative outside, and I'm going to set it equal to the original integral, because we know that the integral of e to the sine x dx is equal to negative e to the x cosine x plus e to the x sine of x minus, because we moved that minus outside, the integral of e to the x sine x dx. Now since this, the integral of e to the x sine x, the integral of e to the x sine of x are the exact like terms, we can actually add this to the other side. So when I add this one to the other side, I'll get 2 times the integral of e to the x sine x equals negative e to the x cosine x plus e to the x sine of x. And I'm not looking for 2 times the integral, I'm just looking for the integral of e to the x sine of x, what that equals. So I can just divide the 2 over. So negative e to the x cosine x plus e to the x sine of x divided by 2 and plus c. And that's our final answer.